Alright, greetings mathematicians. Welcome to another math lesson. Today we're going to be discussing triangle congruence theorems, okay? So here's how my notes are set up. Don't mind those coordinate rules for reflections up there, but we're on a new page here. Triangle congruence, page 11 is what I am on. If it's a little different than yours, that is okay. So our goal for this lesson, in this lesson, I will be able to test and prove triangle congruence theorems. We're going to take a look at those in just a second, but first I want to talk about, well, what does it mean for shapes to be congruent to one another? You guys may remember that congruent shapes, so congruent shapes have congruent parts. Let's say that. Well, what does congruent parts mean? Well, we'll say that, I'll put bullet points here. The corresponding, this is an important word, the corresponding sides are congruent. And we'll take a look at what that means in a second. So there's the first part. Then the second part would be the corresponding, well, we talked about sides, we also need to talk about angles are congruent. If all of the corresponding sides are congruent and all of the corresponding angles are congruent, then we have ourselves two congruent figures. Okay, so let's take a look at this example of triangles here. I have two triangles and I color-coded all of the corresponding parts. So what I would like you to do is go ahead and write congruent statements here. Writing out what parts are congruent to what parts. So, for example, in red, I have the side AC, which I write like this. Side AC is congruent. You ready for this symbol? There we go. We do an equal sign with a little tilde. Let me try that again. Side AC is congruent to what side on triangle PQR? Hopefully you said PR. They are color-coded to help you out. So we say AC is congruent to PR. Let's do some angles. I'm looking on triangle ABC, and I notice that angle A is congruent to which angle on PQR? To angle P. Do you see what's happening here? Okay, so take a second, pause the video, and see if you can list all of the corresponding sides that are congruent to each other and all of the corresponding angles that are congruent to each other. Alright, hopefully you pause the video. Here we go. I'm going to say AB is congruent, side AB is congruent to side PQ. The last pair of sides would be BC, which is congruent to QR. And there we go. Alright, now to finish off the angles, I'm going to say angle B is congruent to angle Q. And then last but not least, angle C is congruent to angle R. Okay, now this process of finding all three sides being congruent and finding all three angles to be congruent can be a little time consuming. So fortunately, mathematicians from ancient Greece have found shortcuts for us. Actually, check my facts on that. I'm not sure if ancient Greeks discovered these shortcuts. I could be wrong. Anyway, double check. Look it up for me, okay? Anyway, shortcuts, or as we call them, theorems, have been created to kind of alleviate some of this tedious work here. Okay, and we are going to be testing and proving some of them, all of them actually. So, if you could, please copy down this table here. I have 6 theorems in total. So take a second, pause this, then take a second and pause here. Okay, make sure you get all of these written down, please. Whoops, I forgot to write the abbreviation angle, side. Okay, so how are you guys going to do this? Well, there's a nifty little website that that was shown to me by another math teacher that you guys are going to use to help you determine, hey, is this an official theorem of triangle congruence? Okay. If it's not, if you cannot prove that the triangles are, well, if it's not an official rule, you should be able to provide a counterexample, and this little web application is going to help you do that. So I'll walk you guys through the first given condition, which is what we call side, side, side. So that means all 3 sides of both triangles, all 3 pairs of corresponding sides are congruent to one another. So let's take a look at the application. All right, here we are on the application. I will post links in multiple places for you guys so you guys can access this. I'll post it in the description of this video. I will also post it on your weekly learning task slideshow, okay? So anyway, we are looking at the first given condition called side, side, side. You'll notice that you have 6 options here. You have sides and you have angles. So we need to pick 3 elements that make a triangle. In this case, we're going to do side, side, side. So I'm going to select all 3 sides. And what's nice is that the program actually tells you what to do to kind of help you along in this investigation of the theorem. So we're testing to see, does side, 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 does this rule, meaning that all 3 pairs of corresponding sides, if they are congruent to one another, does that make the 2 triangles congruent to one another? Well, let's take a look. So I'm going to connect my points. So you click and drag from these orange pieces here, and then on each point you can slide them over and then connect them to their corresponding places. So we make a corner like that, and move this up a little bit. Can see down, there we go. And then of course you have to adjust these here so that way you make a triangle. And there we go. So we've made our first triangle. We are going to use the congruent elements. So remember that these 3 side lengths are congruent to their corresponding sides. So let's make a triangle, and if they make the same triangle, then hey, we know that it is congruent. So let's go ahead and connect our points together. So Q goes with Q, so put that there. U should go with U, so that'll go there, and then H should connect with H. And you might be able to infer, as you're connecting the triangle, like, are these actually congruent to one another? And what's nice is you can actually click and drag. So it might be a little hard to tell, are these actually congruent to each other? So what's nice is you can rotate them. I believe you can flip them. Yeah, you can flip it as well. So bringing it back to our rigid transformations, right? Because our rigid transformations don't change anything about the size or the shape of the triangle. Maybe change its position, maybe its orientation, the way it's facing. And hey, look at that. Are these triangles congruent? You can officially say yes. So what I would do here is I would remove this triangle. I would copy these 2 triangles down onto your table in your notebook, okay? And this is going to go under the congruent column, okay? So draw a rough sketch of these 2 triangles, and it would be a great idea if you showed me which sides are congruent to each other. I'll pan to my notebook in just a second, but I kind of want to show you this last part before. Okay, so the last question you're going to answer. Is it possible to make a triangle that is not congruent to ABC? Well, this is where you guys are going to explore a little bit. So connect your vertices, connect your corners, and see if you can make a different triangle. Sure, I made a triangle here, but remember that all three sides are congruent to one another. So I need to make sure that these V's are actually touching. So once they do, it'll tell you whether or not you created a new triangle. But these triangles are congruent. So because I cannot give a counterexample, something that proves this theorem wrong, I believe that side, side, side is an official shortcut to tell whether or not two triangles are congruent. All right. I'm going to pan over to my notebook and I'll show you guys how I updated it. Okay, so I want to show you guys what you are going to record in your tables here. So we started off with triangle ABC, and remember, it doesn't need to be a perfect sketch, okay? I mean, it doesn't need to be a perfect drawing, so it doesn't need to be drawn to scale or anything like that, okay? So just try your best. So I believe this was A, this was B, and this was C. Again, doesn't need to be perfect. I should have changed colors here, actually. Let's switch to pink. There we go. And this was HQU. And the way that we show that sides are congruent to one another, other than writing out congruence statements, we use tick marks. So the side AB, this side here, we'll put one tick mark inside. That should be congruent to side HQ, so we put one tick mark there. BC is congruent to QU, so I'm going to put two tick marks in there, because BC is definitely not congruent to AB. Right, so we need a little bit of a way to tell them apart. So we just put two tick marks, and then you can imagine that we could keep going, right? So CA is congruent to UH. And there we have our three congruent sides. So are these two triangles congruent to one another? We concluded that yes, they are definitely congruent. So let's write that as well. So we'll say that these two are congruent. So in other words, if I give you a question and ask if the triangles are congruent, and you can prove to me that all three pairs of corresponding sides are congruent to another, then you have yourselves two congruent triangles. And we were unable to give a counterexample, so we'll just write none here. Okay, so if you guys have any questions using the tool or filling out your table here, please let me know. Please come see me during office hours. Please send me an email. Don't worry if your counterexamples are different, because there are a few in here that are definitely not congruence theorems, okay? So you have to test for all of them. But like I said, your counterexamples could be different from the person you're working with, okay? And that's okay. It just shows that, hey, you don't have two congruent triangles. All right, folks, that's it for me, and I will see you in the next lesson.